All right, so with this problem, you do have two options. So if you just like alternative ways of doing things, you could do this. If you like quotient rule, I wouldn't even write this down because I'm going to use quotient rule. I just want to show you this other option. You could do x times x squared plus 4 to the 2 or 1/3 power, negative 1/3 power.
Yeah, me too.
So I'm not taking the derivative right here. I'm just rewriting. So you could do this, and you can avoid the quotient rule altogether. All right, let's just do, since some of you guys are doing that anyway, let's just do this. And then we'll do the next one, quotient rule, and you can decide which way you like best. Okay? All right, so, all right, so if we do it this way, what have we got to use now? We have to use a product rule where this is our f of x, this is our g of x. So you have to use a product rule if you do it this way. So now I'm going to start taking the derivative. So I'm going to label this f prime of x. So x times the derivative of g. So right here's where we got to do all that chain rule stuff. So for my derivative of g, Emerson, what would I get for my derivative here? Not quite. We're doing negative 1/3 minus 1, which is like 3/3, negative 4/3. Okay, times the derivative of the inside, which will be our, no, just the 2x. Yeah. So whenever you're taking the derivative of this, what's in that red box there? So this is your g prime of x. You have to use the chain rule there because, yeah, so you have to use the chain rule to take that derivative. So this was just your f. This part was your g prime of x. Part of the problem here is you feel like you're done because you just did all of that work, but you're only halfway done. Although the other part's much easier, right? So f g prime of x, then you got to do g, so x squared plus 4 to the negative 1/3 times f prime. What is f prime? 1. So we'll label these two. So this was just our g of x. This was our f prime of x. So let's clean this up a little bit before we do the next step. So, well, actually, let's just go ahead and factor out some here. So you should notice that you've got an x squared plus 4 here and also an x squared plus 4 here. So we're going to factor out the x squared plus 4 to the lowest exponent that we have, which in this case is negative 4/3. You always want to take whichever exponent is lowest, which starts to get a little confusing whenever you have negative exponents, but it's still what you got to do there. So I'm not finished with this part. Okay. So what you're doing here is you're dividing this by x squared plus 4 to negative 4/3. Right here, it's just going to cancel for that first term, leaving you this other stuff. So this is like an x over 1, a negative 1/3, and a 2x over 1. So that's going to give you negative 2x squared over 3. And then over here, you're also dividing by x plus 4 to the negative 4/3. So what's that going? Yeah, so like, I'm going to do this over to the side here. You've got x squared plus 4 to the negative 1/3 over x squared, or x squared, that should be a square, plus 4 to the negative 4/3. And you're taking this and moving it up to the top, which is x squared plus 4 to the negative 1/3 times x squared plus 4 now to the positive 4/3. And if we add our exponents, x squared plus 4 to the first power. And that is usually going to happen where it ends up being to the first power, or at least an even number power. So this right here is just plus x squared plus 4 times that 1 that was there, but of course you don't have to write it since it is a 1. You can just subtract. Do negative 1/3 plus minus negative 4/3, which will give you a positive 1. So I'm showing you that so you know where it comes from, but you don't have to write all that down. Yeah. This 1/3. Because you're taking this part, and this part, and just multiplying those together. All right, so we can quotient rule it. We're going to do quotient rule in the next problem to see if it's any better, but you may or may not think it's any better. So I can write this is like negative 2/3 x squared. I could either write it like that, or I could write it like this, negative 2/3 times x squared, like that. So I can put the negative 2/3 x squared and the x squared together, and that's going to give me a positive 1/3 x squared plus 4. Sorry, I made that look like I was distributing. I was not distributing. Yeah, I did not distribute. I'm just combining like terms there. So negative 2/3 x negative 2/3 x squared plus this 1 x squared right here. Yeah, I could distribute that 1, but yeah, negative 2/3 x squared, and it's like plus 1, so that's like 3 over 3 x squared, and that's going to give you 1/3 x squared. It's probably not going to be how they leave it. They'll move this to the bottom. Yes, on FRQ. Actually, on FRQ, you could have stopped right here, Thomas. FRQ. You don't have to simplify. Unless, I mean, a lot of times you need it for the next step, so you're going to have to simplify some. But FRQ, you can stop here, but these show up on multiple choice a lot. Yes, it's a lot. Like, the only difference with it in 26 is that you started off with a negative exponent, where over there you had a positive 1/2, but it ends up being pretty much the same process. So we got 1/3 x squared plus 4 over. Yeah, I don't know if they'll change. I don't know if they'll do x squared plus 4 to the positive 4/3, or they might change that back to a root there. Either one. They might do either one. But what I do know is they don't like to put fractions inside of fractions. They don't like that 1/3 inside of a fraction. So Daniel says I should multiply everything by 3. You can't quite just put the 3 on the bottom because of that plus 4 over there. If it was just a 1/3 x squared, you could just move the 3 to the bottom. No, I'm not going to erase it. So I'm going to multiply the top by 3 which will give me x squared plus 12. And on the bottom, I'm just going to leave that factored out. 3 times x squared plus 4 to the 4/3. And this is probably how they leave it. If they don't leave it like this, they'll leave it like this. They might do 3 cube root x squared plus 4. I don't think they'll distribute, but they might write it as a root. I don't like it written as a root because you got that 3 and the cube root there. So the hardest part about these is definitely simplifying, because you were done with calculus after step 1. That was the only calculus that you were doing. In the grand scheme of things, no, but like right now, yes. You have taken the derivative right here, but you're gonna, like, whenever you work these problems on your assignment, you want to check the back of the book for, at least for the odd ones, and try to make sure you're getting the same thing that they get, because that gives you some practice like you would see if you were doing like a multiple choice question, because the answer choices will look probably like one of these two on a multiple choice question. All right, let's try one, and let's do quotient rule just to see if you guys like it better. Or let's say it this way. Let's see if you hate it less than you hated what we just did. If you're maybe possibly not a fan. Now you do want to, if we're going to use quotient rule, we do still want to think about this as x squared minus 4 to the 1/2 power. Here. But if we're going to do quotient rule, we're going to leave it in the denominator. We'll get into some of like the applications of derivatives. Really, it'll mostly be the unit 4 where we look at that. But we'll get to some of the applications there. So it would be like if you had a problem, you would use this. The reality is computers will do a lot these days, but if you are, like, because your calculator can take the derivative of this, but understanding, like, how to work, like, how the math works to, like, do that is going to be necessary if you're operating, like, at a high level of this. So, like, if you are a physicist, then you need to be able to do this, like, in your sleep, because you're going to have, like, crazy math coming at you that you just need to understand how the numbers work. If you are like, I got to take Calc 1 as a weed out class to do whatever my major is going to be, then you're probably not going to use this ever in your life. But whenever you take Calc 1, it's not like there's a special Calc 1 for those who are just taking it as a weed out class and those who are going to be physicists. So, you know. Yeah. Mm-hmm. Calc 3 is calculus of multivariables. So it is going to be like kind of like the same stuff we're doing here, but there will be an X, Y, and Z axis. So it's 3D. It's 3D calculus. Calc 2, class, like, we will do all of Calc 1 and about a third of Calc 2 in this class. That's the way they design AP. Well, AB does all of Calc 1 and about a third of Calc 2. If you take BC, it's all of Calc 1 and Calc 2. So, like, you guys will get credit for Calc 1 if you pass the exam and get credit for it. If we were teaching BC, then you would get credit for Calc 1 and Calc 2. Most schools that teach BC teach AB for a full year, and then so like you would take calculus your junior year, and then you would take BC for a semester your senior year. Although, yeah, so we typically have not had enough teachers to do that or enough students that were, ready to do that. So we have not done. I would have to go back and yeah. I have certainly taken Math 2, Calc 2, and did well in it when I took it, but I've forgotten a lot. So when I took calculus, I had to go back and read it. You go to like a training. You don't have to like take a test or anything, but you do have to go to training. Mm-hmm. The hardest math classes I took, probably abstract algebra was like the hardest class I had. Well, if you major in math, I realize y'all are just getting out of this question, but if you major in math, I thought whenever I majored in math that I was gonna like just keep taking harder and harder math classes, like with harder and harder problems. No, it is not how it is, Alfredo. I was not quite ready for this. So you're going to take a few that are harder and harder. You'll take Calc 2, Calc 3. You might take differential equations and a couple other classes. You have to have some stats. But then most of your other classes are the proving of stuff you've already taken other classes on. So like abstract algebra was a proof class where I just had to write like paragraphs about why certain things in algebra work the way they did. And had to like, it's justifying, it's logic is what it is. I mean, I was, yeah. Yeah. So I did have some classes. I also had modern college geometry. It was kind of cool. It like a geometry. We think of geometry as just like shapes, but that is you. A geometry can be anything that has theorems that you set and postulates that you are set as rules. So like everything you've learned so far about geometry has been Euclidean geometry. But there's like, for example, there's spherical geometry. And in spherical geometry, a line is a circle. Yeah, a line is a circle. So it's like everything on a sphere. It's actually really applicable because the world is a circle, is a sphere. So like whenever you're, the world is a sphere. So like it like actually does apply to like a lot of things. Like if you want to launch a rocket from here to North Korea or something. But anyway.
What's the weirdest symbol
I didn't run into anything too crazy. We'll see if you in here you haven't seen before that I like. But anyway. But there was a lot of proving that I was not ready for. I kind of liked it. And I have a Bachelor of Science in math. So, like, some teachers get like a secondary math education degree, not a math degree. So I don't think they have to do a lot of the classes that I had to do. But at Meredith, you had to major in math and then just took like extra education classes. It's a lot. Yeah. It's a lot harder. Yeah, like it's a lot. A Bachelor of Science in Math is a lot harder than the education degree. So, education math degrees still have to take a lot of higher level math. It's not, I don't want to call it easy, but you have to take, like, I don't think they have to take as many proof classes and stuff as I had to have. So, no, I think most like mathematicians probably have master's and doctorate degrees, and I don't have those. But But you couldn't go. You wouldn't need a BS in math, I think, to go get a master's or a doctorate. Not really. Not. If I ever did, I would get a master's degree so I could teach, like if I ever wanted to teach at a community college or something. Yeah, you only get pay raises for national boards. You don't get them for master's degrees. So sometimes, I mean, I would kind of just like to go do it to learn, but I don't have time for that. So, yeah. But that one, this is my favorite math symbol. You will learn it. Yeah, I like it even better than 3 dots. Although I like it because it's over. It is an integral symbol, and so Calc 1 is all derivatives. If you take it in college, Calc 2 is integrals. We do some integrals, so we get into some of Calc 2. They design it that way because for AP, like if you pass the exam and get credit for this class, then they don't want you going into Calc 2 without ever seeing any of it, and like it's your first experience in college and you like have a heart attack whenever you start doing all this difficult stuff. So we do all of Calc 1 and about a third of what you would do if you were taking Calc 2 at in college. So if you pass it and you start in Calc 2 whenever you go to college, if you need Calc 2, then you should, like the first third of the class should be things we've already done, which is really a good thing so that you're not like thrown in and shocked when you get into Calc 2. So we do, but we won't until probably second semester. Yeah. I think he has a math degree too. Yeah. Catawba College. I think Miss Ball has, I think hers is math education, but I'm not 100% sure. I don't know the answer to that question. I don't know.
Yeah, we should have a math contest with every math teacher.
Yeah. I don't know about Coach Brown. I will be. Now, if it were like higher level math, I would probably win because if you don't do calculus, you forget it, and they have probably forgotten a lot of it. But if it was just like hard problems but not higher level math, I don't know. He definitely has. He memorizes he definitely has things memorized better than I do on some stuff. Now I don't know. I mean, I feel like maybe we should have this competition.
I think it really should. All math is so cool.
Yeah. Everybody will come to see Coach Wood and I have a math competition.
Yeah.
Be the event, the social event of the season, right there.
Instead of powder puff.
Yeah. Instead of powder puff, Coach Wood and I will have a math competition. Yeah. So have now what would be maybe kind of fun is if all because I don't really want to compete against the other math teachers, but if we had a math teacher team and had quiz balls to go against other schools, we could take out East Wilkes. I'm a little afraid to lose, yeah. I don't know. It also might not be good for, it might not be good for us if we're all in competition to be. We work together. So, and, even though I will admit,
I think a teacher math team at each school, they just
yeah.
compete. That would be hilarious.
Yeah. That would be, that would be great. Yeah. The 4 of us, we could take on North Surrey, East Wilkes. Yeah. Yeah.
We had a senior project. That's what mine.
Yeah. Once again, none of us have time for this, and we should be doing this problem instead. But you guys have got me off track for a while, so good job.
I've done some.
Somebody wake Thomas back up. Be nice to him. Nice. We're back on track, Thomas. Quotient rule. Okay, if we use quotient. Yeah. Thomas mostly just falls asleep whenever I'm off topic. Okay. Alright, so.
That gave me a lot of time to work on it.
Alright, so if we use quotient rule, low times the derivative of the high minus high times the derivative of the low, which here is going to be where we have to use our chain rule. So Noah, what are we going to get when we take the derivative of that low there?
I got 2x to the negative 1/2. That's probably wrong.
Yes, that's wrong. So you cannot take the derivative of the inside.
Okay, so what it would be?
So,
It would be 1/2.
1/2.
Squared minus 4 raised to the negative 1/2.
Almost.
Times 2x.
Times 2x. Good. Yeah. All over.
X squared minus 4.
X squared. 2 half squared.
And that's done.
It's just going to be 1, yes.
And that's all for FRQ.
Yeah, if this was FRQ, you could technically stop here. Although usually, as long as you don't have to use it, you usually. Sometimes there are a few times you don't, but
Imagine actually trying to use that. Yes, do something like 1.
Yeah.
Does the bottom one do what's intellect? Something was half prime of 3.
yes.
Give me like 5 minutes.
Yeah. Now the good thing about the good thing about it though is like if you have to plug 3 in, it doesn't matter how far you have simplified it. So you may like simplify it one way, and somebody else might stop like earlier, and it can still work. Like technically it can work if you plug in 3 here, but like I said, it's be difficult. So, okay. So right here. All right, so you've got these two match. So we're going to do that same thing. I think I like it better without the quotient rule. But you can do it which way you would like. So we're going to take out to the negative 1/2 right here. The reason that we want to factor it out is because like all of this is the same, so we can like combine that to simplify. So since we got x squared minus 4 and x squared minus 4 here, if we pull them out and put them together, then it's, and especially since the denominator also has that, we can eventually like put all that together to sort of simplify. It'll be shorter if we do that. So what, it's kind of like, Thomas, if we had, like if you had something like x squared minus 3x, right? You would factor out x and have x times x minus 3. So like what you've done there is you divided this by x and this by x, and you pulled that x out here, and then you had your x minus 3 here. So you're doing that same thing, but with that larger expression.
So it should be 2 minus 2 times 2x.
So what's the little trick? So this right here is just, you're just going to have, actually no, sorry.
For the interruption, this time any ROTC cadets who are in uniform would like for them to report to the ROTC room to participate in the lowering of the flag ceremony. Thank you.
Okay, so like you're factoring this out, which means you're dividing by that amount. So if you have a 1/2 on top and a negative 1/2 on bottom, then it's going to move this negative 1/2. This is a negative right here. It moves up to the top, and when you add 1/2 and 1/2, you're going to get 1 there. So you're going to have, I'm going to put this 2 right here out front, and you'll have x squared minus 4 to the first power. It's okay to distribute. So let me.
Why are we putting it back in if we took it out?
We can simplify it now.
That's what it turns into when you take it out.
Yeah, when you take out, it was to the 1/2, and so by doing what we did here, you know, that negative 1/2, this stuff moves up to the top, and then we can combine them together. So it at least gets rid of the 1/2 exponent. So now we just have a x squared minus 4. And then, over here, these are just going to cancel because they both have the same exponent. So they just cancel. The x squared minus 4 to the negative 1/2 and the x squared minus 4 to the negative 1/2. So when we divide out there, it just goes away. So we've got, I'm going to make this 2x over 1. We got 1/2 and another 2x over 1. No, this one's the one that has the negative exponent.
Yeah, and the other one doesn't, so if you divide by negative 1/2.
You know, you're moving that other one to the top. So it's like you're taking this up to the top here, which makes it a positive 1/2, and then you're doing 1/2 times 1/2. So you're not dividing those exponents, you're moving it to the top and adding them. Does that make sense? It usually ends up being a 1 if you're not sure about it. So you get, if you multiply the numerators of all of this extra leftover stuff here, so if we look at, we're looking at, sometimes it's easy to lose something right here. We're looking at these 3 pieces right here that did not cancel out. In your numerators, you're going to get 4x squared. In the denominator, you'll just have a 2. So if you want to, you can go ahead and make that a 2x squared. So all your numerators, 2x, 1, and 2x here. So that 2 times 2 is going to give you the 4. You don't have to have common denominators to multiply because you're multiplying here. There's a lot. So we're going to distribute that 2, so we got 2x squared minus 8. It is 2x squared. Right here. So this 1/2 right here and the square, we multiply those exponents when we raise a power to a power. So 1/2 times 2 is just going to have this to the first power. We're at this x squared minus 4. Yeah, it's not going to be squared. It's just this x squared minus 4 to the negative 1/2. And so we could, these 2x squareds are going to cancel. And so that, if we move this stuff with the negative exponents back down to the bottom, I'm going to show every single step just so you follow my logic, but I probably wouldn't write this if I was just doing the problem. So in the top, all I've got left is that negative 8. In the bottom, I've got x squared minus 4 to the 1/2, and I got an x squared minus 4 to the first power. So what will I get when I combine those in the denominator? Yeah, I'm going to write it this way first, x squared minus 4 to the 3/2, because sometimes you'll see it just written like that, and then sometimes they'll change it back to the root. The way we did it the first time. Yeah, I think I like it better without the quotient rule. I think I like just doing product rule. But either one.
Well, when you plug into anything other than a 1 or a 0, it's going to be really different.
Right.
It has just be one.
Yeah.
Zero. Like you can look at that beginning where you circled the x2 minus 4.
Right here.
Two steps down.
Right here.
Yeah.
Okay, so what I did is, since this had a negative exponent, I just moved it down to the bottom.
And that makes it.
Right. And that makes it a positive 1/2. And this one just had an exponent, didn't have an exponent, so it was a 1. And so since those two are the same, you can just add their exponents. So 1/2 plus 1 will give you 3/2. Yeah, I think I like the other way.
I don't even understand the other way, but this one is more work.
This is worse. Okay. So.
There's more things that I understand in this one. The ones for the 2 equals.
Okay. All right. All right. Let's try this one. I think you can fit it there if you don't space it out very much. Just squeeze it. Daniel never is going to ask me that question, is he? He will never run out of room.
No, he will find a way.
Even if the entire main page is out, you can just like work like along
The margins.
the entire paper. You know? That's the and so you've used all this, you can just start like doing it. That's what I used to do in physics. In physics I used to turn with the paper.
Daniel makes
So my problem would like start like this, and my answer was like down here, but it like curved.
What the heck? Oh man, that's so good.
Okay. All right, so let's do product rule again.
Do that part.
Okay, so we have not taken the derivative, we're just rewriting it.
Yep.
All right, so Thomas is going to help me on this one. All right, so we've got to use a product rule here because we got two expressions that both have x's in them. So product rule is f times g prime plus g times f prime. So what are we going to get whenever we do this?
We're going to get 3x squared, parentheses, negative 1/2, x squared minus 3, multiply into that, and that's times 2x, parentheses out.
Almost. You forgot one thing. When you multiply it out here by the negative 1/2, what do you have to do to your exponent? Yeah. And so 1/2 minus 1 is going to give us negative 3 over 2. Yeah. Okay, good? Okay, so let's think about what you've already done. Okay, because you did that perfectly almost.
Tommy does no more left.
All right, so you did f. All of this stuff right here was just your g prime of x. We got to add? He's treating his paper like a whiteboard. Okay.
So good, Tommy.
No, that's cool. Okay, so we're going to do plus.
You got
Plus x squared minus 3 to the negative 1/2 times 6x.
Wonderful. So you get this? You've got what you gotta have to get the derivative correct on FRQ. But it's hardly ever going to be left like that if you see it anywhere else. And if you got to plug a number into it, it's going to be difficult to do. So,
You can do that 3x and that 2x, now we get to 6x to the third. Yep.
yes. And while we're at that, so if we do 3x and 2x, we also can multiply that, negative 1/2.
No, I'm good.
Let's go ahead. All right, so we've got 6. No, not 6. We got, if we do, you don't distribute because it's got that -3 to the -3/2 power.
See, there's another rule that I just don't understand.
Yeah, you cannot distribute if you have a power on the parentheses. So 3 times 2 times -1/2 is going to give us -3x to the third. And we're just going to write x squared minus 3 to the -3/2. And then I'm going to write the 6x out front here. Okay. All right, so we should notice that, these two things right here are the same.
Yes, we do that with the factor thing now.
Yeah. Do the most of the time. So x squared minus 3 to the -3/2 is going to be out front. Okay. So we will take the lowest exponent, which is -3/2 in this case.
So it doesn't have to be a common.
Right, you always want to take the lowest one. Yeah, always take the lowest one. So what we're doing when we do that is we're dividing this right here by x squared minus 3 to the -3/2, which is great because that will just cancel. And then over here,
I got space for that. I've already started the other problem right below it.
okay.
So I can't divide it.
So it's okay if you don't have to write that step.
I'm just joking.
So we'll have this 6x. What happens when I got that -1/2 and that -3/2? It's going to be a 1. So it's going to be x squared minus 3. Because if we move that 3/2 to the top, it'd be positive. And then -1/2 plus 3/2 would give us 1. And so at this point, you're just going to distribute that 6x. So -3x cubed plus 6x cubed minus 18x. And then we're going to simplify. And we'll have you can. So you might see the answer just look like this, 3x cubed minus 18x, and then they'll move this back, x squared minus 3 to the 3/2. They'll move it back down to the bottom, or they might factor out a 3x. So it just depends on how they leave the answer. Okay, so let's see here. We didn't quite finish all I had, but let me see. Which is great news for you guys. So you do have a little tiny bit, but it is just It's just 27 and 28 on page 168. I mean, we were not working very hard today. 168.
I was indeed also working.
They are just like the ones that we did. 168, 27, 28. Yep.